Hello. In today's video we are going to see how to study the variation of some exponential functions and then how to draw the graph of these functions. In the first function we have f of x equal e to x minus 1 over e to x plus 1. In order to study the variation of this function, in order to draw the graph of this function, we have several steps to follow. The first step is to determine the domain of the function. Okay, so in order to determine the domain of this function, we have to set the condition. My condition here is the denominator shouldn't be 0, so e to x plus 1 not equal to 0 means e to x not equal negative 1. When e to x not equal negative 1, in fact this is always true because e to x is strictly positive, so this is always true, which means the domain of this function is minus infinity plus infinity. The next step is to determine the limit over the boundary of the domain. So here we have to find the limit as x approach minus infinity f of x, which is the limit as x approach minus infinity of e to x minus 1 over e to x plus 1, which will be, as x approach minus infinity, e to x will be 0 minus 1 over e to x, again it's 0 plus 1, so the answer is negative 1. So in this case we have the line y equal negative 1 is a horizontal asymptote. Now, what will be the limit as x approach plus infinity? As x approach plus infinity, this is the second boundary, right, of f of x. It will be again the same thing, limit as x approach plus infinity of e to x minus 1 over e to x plus 1, which is, since as x approach plus infinity, e to x approach plus infinity, so the answer will be plus infinity over plus infinity, which is an indeterminate form. So this indeterminate form, we can solve it using HR Hopital's rule. So this will be the limit as x approach plus infinity, the derivative over the derivative. The derivative of e to x is 2e to x, because the derivative of eu is u prime eu. So the derivative of e to x will be 2e to x. So let's apply it here. So we get 2e to x over 2e to x, which is 1. Hence, the line y equal 1 is another horizontal asymptote. The next step will be the derivative and the table of variation. So what is the derivative of this function, f prime? This function has the form u over v, right? So in order to find the derivative of any function of the form u over v, we should use u prime v minus v prime u over v squared. So this is u and this is v. So f prime in this case will be u prime times v minus v prime times u over v squared. So applying this rule, u prime, it's 2e to x, right? 2e to x times 2e to x times v, which is e to x plus 1, minus v prime, which is the same, e to x, times u, which is e to x minus 1, over v square, which means e to x minus or plus 1 square. Let's simplify this expression. What do we get? 2e to x times e to x is 2e 4x, because 2x plus 2x, it's 4x, plus 2e to x times 1, it's 2e to x, minus 2e to x times e to x is 2 or 2e 4x, and minus 2e to x minus 1, it's plus 2e to x, all over e to x plus 1 squared, which will be equal to 2e4x minus 2e4x cancelled, 2e to x plus 2e to x, it's 4e to x over e to x plus 1 squared. Now since e to x is strictly positive, times 4 it's positive, over something squared which is positive, so this is strictly positive for all x in the domain. Hence, the table of variation for this function will be, this is x, this is f prime, and this is f. The domain, it's minus infinity plus infinity. F prime, we said it's strictly positive, so it's all over the domain, it's positive. Hence f is strictly increasing. As x approach minus infinity, we have seen it will be, the limit will be y negative 1, which means y equal negative 1 horizontal. And at plus infinity, the limit was 1, which means y equal 1 horizontal asymptote. So here y equal 1 horizontal asymptote. So this is the table of variation for this function. The last step, or the last step before the graph, is particular points or the intercepts. Let us try to find the x-intercept first. How to find the x-intercept? The x-intercept, it is to solve y equals 0. Y equals 0 means the function equals 0. The function, it is e to x minus 1 over e to x plus 1 equals 0. Hence, the numerator equals 0, e to x minus 1 equal to 0, which means e to x equal 1. Setting len both sides, so len e to x equal len 1, which is 0. So 2x equals 0 means x is 0. So the particular point here is the x-intercept, which is 0, 0. If I try to find the y-intercept, we are going to get the same point, but let me work it. If I try to find y-intercept we solve x equals 0. So if I substitute in the function instead of x0, it means I find f of 0. We're going to get e0 minus 1 over e0 plus 1, which means 1 minus 1 over 1 plus 1, which is 0. Hence we are going to get the same point 0, 0. So now we get all the points we need to draw the graph for this function. So in order to draw the graph of this function, as a first step we should draw the asymptotes. So if I try to draw the graph here, this is x, this is y. We have y equal 1 horizontal asymptote, this is y equal 1, and y equal minus 1 another horizontal asymptote. A particular point it is at 0, this is 0. So the graph or the table of variation says that the graph will start from minus infinity of the horizontal asymptote, y equal minus 1. This is y equal minus 1. So minus infinity, it means from the left side, from here. It will go up to plus infinity of the second horizontal, y equal 1. So from here till here. So the graph will be, okay, from minus infinity up till plus infinity of the second asymptote. If I want to check this graph with a better graph on GeoGebra, let us try to work this using GeoGebra. If I want to skip these. Let us try to draw the graph of f of x, which is equal to e 2x minus 1 minus 1 divided by e 2x plus 1 plus 1. Let us check the graph of this function. I lost it, I think. So let me draw it again. So e power 2x minus 1 divided by e 2x plus 1. So this is the graph. So okay, if we draw the graphs now for the horizontal asymptotes, we have y equal -1. This is the first horizontal asymptote, and the second one is y equal 1. So these are the asymptotes. Okay, let me draw them as dotted lines. So this is the first asymptote and this is the second one. So this is the graph of the function. Okay, if we go now to the second function, in the second function we have f of x equal x plus 1 e minus 0.5x. So first, the domain, since this function is defined everywhere, so the domain is minus infinity plus infinity. Now to find the limit as x approach minus infinity, of f of x, it will be x plus 1 will go to minus infinity multiplied by e minus 0.5x will go to plus infinity. Since minus 0.5x will go to plus infinity, e plus infinity is plus infinity. Minus infinity times plus infinity, it's minus infinity. Now limit as x approach plus infinity, f of x, it's going to be x plus 1 will go to plus infinity multiplied by e minus infinity, which is 0, which is an indeterminate form. Now in order to solve this indeterminate form here, first notice that we have here negative 0.5, e negative 0.5, so we have a property that says e minus x equal 1 over ex, so that's what we are going to do here. So this will be limit as x approach plus infinity of x plus 1 over e 0.5 x. So applying the limit here, we are going to get plus infinity over plus infinity, which is indeterminate form, but here we may apply Hopital's rule. So applying Hopital's rule for this one, we are going to get limit as x approach plus infinity of 1 over 0.5 e 0.5x, which will be 1 over plus infinity, which is 0. So this means y equals 0. The line y equals 0 is a horizontal asymptote. So now derivative and table of variation. This is a derivative. The derivative of this function is, since this function has the form u times v, this is u and this is v, so the derivative of f will be, according to the rule, it's u prime times v plus v prime times u, which will be, if we apply it, u prime it's 1 times v, which is e minus 0.5x, plus v prime it is minus 0.5 e minus 0.5x times u, which is x plus 1. So this is equal 1 times e, it is e minus 0.5x. Now plus minus, it means minus 0.5 e minus 0.5x multiplied by x plus 1. If I expand here, this one times this one and times this one, what do we get? This will be equal e minus 0.5x minus 0.5 e minus 0.5x times x, it will be minus 0.5x e minus 0.5x and minus 0.5 e minus 0.5x, which is equal. We may add this term with this term, so here we have 1 e minus 0.5 e, it's going to be 0.5 e minus 0.5x minus 0.5x e minus 0.5x. If we take minus or 0.5 e common, 0.5 e minus 0.5x, because we have both, in both terms we have 0.5 e, we get 1 minus x. If I solve it equal to 0, it means 1 minus x equals 0, so x equal 1, because the second factor can't be 0. So table of variation, this is x, this is f prime, this is f, domain minus infinity plus infinity, we have the critical value 1. If I try 0 before 1 and substitute it in f prime, this is f prime, It's enough to substitute it in this factor because the first factor is always positive. This is always positive. So 1 minus 0, it's 1, which means positive. So this side negative, so it's increasing, decreasing. As x approach minus infinity, the answer was minus infinity. As x approach plus infinity, we get y equals 0 horizontal, so we put here y equals 0 horizontal. Now let's find intercepts. Okay, if I find x-intercept, we solve y equals 0. It means the function equals 0, which is x plus 1 times e minus 0.5 x equals 0. So x plus 1 is 0 because exponential can never be 0. So this means x equals negative 1. So the x-intercept is negative 1, 0. Now y-intercept, we solve x equals 0. So this means f of 0, it will be 0 plus 1 is 0, which is 1. So the y-intercept is 0, 1. So let me draw a rough curve here, and then we'll draw it again clearly on GeoGebra, using GeoGebra. So this is x, this is y. So first we should draw the asymptote. So we have y equals 0 horizontal, y equals 0 means the x-axis. So let us draw x-axis as dotted line. So let's draw it as dotted. This is horizontal asymptote. Okay, now once I draw the asymptotes, now let us draw the maximum. The maximum here is 1 with abscissa 1. Now substituting or finding f of 1 to find the ordinate of this maximum. If I try to find f of 1, it's going to be 1 plus 1 e minus 0.5, which is using the calculator we can find it's going to be equal to it is 1.21. So let us draw here the maximum. It's 1.21. It's almost here. This is the maximum. And we have the intercepts minus 1, 0. This is minus 1, 0. And we have 0, 1. This is 0, 1. Okay. So the graph, according to the table of variation, it says it will start from minus infinity x minus infinity y. It means from the third quadrant we'll go up to the maximum, okay, passing through the intercepts. So from minus infinity we go up to the maximum. Then from the maximum we go down to plus infinity of the horizontal asymptote. So plus infinity of the horizontal asymptote, it means to here. So this is the graph. To make sure, let us draw the graph on GeoGebra. So this is f of x, which is equal to x plus 1 times exponential e power minus 0.5x. So this is the graph. So let us check the maximum. So this is the special point B, which is the maximum, 1.21. Let's go now to the third part in the third part we have f of x equal 1 plus 1 minus x e x plus 1. So again we start by finding the domain. So obviously this function is defined everywhere, so the domain here is going to be minus infinity plus infinity. So the limit as x approach minus infinity f of x is going to be, so 1 plus 1 minus x, it's going to be plus infinity because x is minus infinity times minus, it's going to be plus infinity, e minus infinity, which is 0. So we have here indeterminate form. So in order to solve this indeterminate form, I may expand with the exponential as x approach minus infinity of 1 plus e times 1, it's e x plus 1 minus x e x plus 1. So as x approach minus infinity, so this will be limit as x approach minus infinity into 1 plus e x plus 1 minus x e x times e, right? Because ex times e1 is going to be ex plus 1. Why we did this? To use the property that says the limit as x approach minus infinity, x ex will go to 0. So this is what we are going to use here. So we get 1 plus the exponential here, it becomes e minus infinity, which is 0. Now x ex will go to 0 as x approach minus infinity. 0 times e, it's going to be 0. So we are going to get 1. Hence, we are going to have the line y equal 1 horizontal asymptote. Now, let's find the limit as x approach plus infinity. Now, as x approach plus infinity f of x, this is going to be 1 plus minus infinity, because minus x will go to minus infinity, e plus infinity, which is plus infinity. So we get 1 plus minus infinity into plus infinity, which is minus infinity. So this is the limit as x goes to plus infinity. Let's try to find f prime now. F prime. So first the derivative of 1. So if I find the derivative of 1, it's going to be 0. Now this has the form u times v. To find the derivative of u times v, we are going to use u prime v plus v prime u again. So first derivative of 1 is 0 plus u prime, it's minus 1 times v, which is ex plus 1, plus v prime, it's ex plus 1. The derivative of ex plus 1 is ex plus 1, right? Because the derivative of eu is u prime eu. So this is u. The derivative of x plus 1 is going to be 1 times ex plus 1. 1 times ex plus 1, it's ex plus 1. So this is v prime times u, which is 1 minus x. So let's simplify here. Minus 1 times e, it's minus e x plus 1 plus e x plus 1 minus x e x plus 1. So e x plus 1 minus e x plus 1 cancelled. So this is f prime. I solve it equals 0. It means minus x equals 0. So x is 0. So this is the critical value. Table of variation. This is table. This is x. This is f prime, and this is f. So from minus infinity till plus infinity, critical value 0. So if I substitute, so here f prime is 0 at 0, Now, if I try value before 0, minus 1 for example, substitute minus 1 here, so minus 1 times minus, it's plus 1. So here plus, here negative, so increase, then decrease. As x approach minus infinity, we have seen we have y equal 1 horizontal, and as x approach plus infinity, it's minus infinity, and at 0, the maximum, if I find f of 0, it's going to be 1 plus 1 minus 0, e 0 plus 1, which is 1 plus e, which is approximately 3.7. So if I draw the graph here, so we have, this is y-axis and this is x-axis. We have y equal 1 horizontal, this is y equal 1 horizontal. We have a maximum 0, 3.7, this is 0, 3.7, this is 1, 2, 3, almost here, so this is the maximum. So the graph will go from minus infinity of the horizontal, minus infinity of the horizontal, we go up to the maximum. From the maximum we go to plus infinity x minus infinity y, means to this quadrant. So this is the graph. Now in order to check the graph, okay, let's us try to graph f of x using GeoGebra. We have, this is f of x, which is equal 1 plus 1 minus x multiplied by e x plus 1. So this is the graph. So let us check points, the special points. So these are the special points. Okay, so this is the maximum, and let us draw y equal 1. This is the horizontal aspect. So this is the graph. So that's it for now. See you in the next videos. Thank you.